So another differentiation question, this time implicit differentiation. So we're trying to find an expression for dy dx initially. So if I take this expression, I'm going to multiply the brackets out. I'm going to expand the brackets. So I get this expression here, this equation here. And what I'm going to do now is to differentiate each of these terms separately. So I'm differentiating with respect to x. Now, when I differentiate a function of y with respect to x, I have to differentiate with respect to y and then multiply by dy dx, because differentiating with respect to x is equivalent to differentiating with respect to y and then multiplying by dy dx. So differentiating with respect to y gives me 4y cubed, and then I multiply by dy dx. The second term here is a little more tricky because I've got two functions multiplied together, so I need to use the product rule. So I'm saying minus 6x times y squared. So the differential of that is I differentiate the first one, which is minus 6, and then multiply that by the second one. And then I differentiate the second one, which is 2y dy dx, and multiply that by the first one. So differential of the first multiplied by the second, plus the differential of the second multiplied by the first. So those are the two terms I get from differentiating minus 6xy squared. Then differentiating the 9x squared is straightforward, and the differentiating the minus 10 goes to 0. So I've now got an equation which has got dy dx in it in two different places, and I've got these two terms which don't have dy dx in them. So I take those over to the other side, factorize out the dy dx, and then dividing by this bracket gives me an expression for dy dx, which I can tidy up a little bit. It's got the numerator and the denominator have got a common factor of 2. So that gives me my simplified expression for dy dx, a function of both x and y. So now we've got to find the gradient of the curve at the points where it intersects the y-axis. Well, on the y-axis, of course, x equals 0, so I can put 0 here. And when I do that, I get x to the power 4 equals 10. So, sorry, y to the power 4 equals 10. And that gives me values of y of plus or minus the 4th root of 10. So to find the values of the points where it intersects the y-axis, I need to put those two values for y back into my original equation. Into the trying to find the gradient we need to find the gradient, pop that into there. So when I pop this positive square root of 10 in for y here, and x equals 0 here and here, pop that into my calculator and I get a value of 0.844. When I put the negative 4th root of 10 into the expression for dy dx, I get minus 0.844. So those are the gradients at the points where the curve cuts the y-axis. Phew.